Hi guys, in today's lesson, I'll be teaching us energy changes under thermochemistry. And I know you guys wouldn't want to miss this. And if this is your first time coming across my video, I want you to subscribe to my YouTube channel at Divine Online Chemistry Tutorial. So let's get started with the lesson of today. I'll be starting first with what? With enthalpy. Now, what is enthalpy? Please take note that enthalpy is simply the heat content of a chemical reaction. So please take note that enthalpy is simply what? The heat content. Please take note that enthalpy is simply what? The simply the heat content of what? Of a chemical reaction. So please take note of this. And please take note that in a chemical reaction, the special at the left hand side is known as what? As the reactant. So please take note that the special at the left hand side is known as what? As the reactant. It's known as what? As the reactant. While the one at the right hand side is known as what? As the product. So please take note of this, that the species at the left hand side is known as what? As the reactant, while the species at the right hand side is known as what? As the product. So please take note that the reactant, they collide together for the products to be what? To be formed. And earlier on, I said that enthalpy is simply the heat content of a what? Of a chemical reaction. Now please take note that H, the symbol H, is used to denote enthalpy. So the symbol H is used to what? To denote what? Enthalpy. So please take note of this symbol. This symbol H is used to denote what? Enthalpy. Now, please take note that change in enthalpy can be denoted with this symbol. Change in enthalpy can be denoted with this symbol, where we have this triangle sign here, and then with H. You know, H is what? Is the enthalpy. Now, this triangle sign is known as what? Delta. Please take note of this, that the triangle sign is known as what? Delta. Whereby this H is known as what? As enthalpy. So if you combine the two of them together, you have delta enthalpy. Now please take note that delta means change in. This delta, it means what? Change. It means what? Change in. So please take note of this, that this delta means what? Change in. Whereby the H is what? Enthalpy. So if you combine together, if you combine the two of them together, we have change in what? Enthalpy. Change in enthalpy. So please take note of what? Of this. Now, like I said earlier on, I said enthalpy is simply the heat content of what? Of a chemical reaction. And then I went on to say that the symbol for denoting enthalpy or for representing enthalpy is this capital letter H. So this is symbol for representing what? Enthalpy. So this capital letter H is what? The symbol for representing what? Enthalpy. And then I said change in enthalpy can be represented with this symbol, where we have this triangle sign here, then with the H, which happens to be what? The enthalpy. And I said that this sign or this symbol is known as what? Delta. And the meaning is what? Change in. And the whereby this H is known as what? Enthalpy. So if you compare the two of them together, we have what? Change in enthalpy. So please take note of what? Of this. Now, what does change in enthalpy means? Change in enthalpy simply means the difference between the heat content of the product and the heat content of what? Of the reactant. So that's what change in enthalpy means. You see this word change in enthalpy. It means what? The difference between the heat content of the product and the heat content of what? Of the reactant. Mathematically, it can be represented like this. Change in enthalpy, which happens to be delta H, is equal to what? Product minus reactant. So please take note of this, that mathematically, change in enthalpy can be written like this, where we have the change in enthalpy, which is this. Then we have what? Equal to what? Product minus reactant. So please take note of what? Of this equation. It is very vital when calculating what? Change in enthalpy. So change in enthalpy is simply the difference between the heat content of the product. You can write product here. You can also write heat content of the product. It's still correct. So it's simply the difference between the heat content of the product and the heat content of the reactant in a chemical reaction. So please take note of this equation or of this formula. Now from here, let's talk about the unit of enthalpy. Now please take note that the unit of enthalpy is the joule. So unit is equal to joule. So this is the unit for enthalpy. You can also write it like this: joule is the joule. So you can spell it, but it's advisable to write it like this, capital letter J. So this is the main unit for enthalpy. Or the other unit can be kilojoule per mole. Kilojoule per mole. So please take note of this. So the unit for enthalpy is it's either the joule, which is the main unit, or kilojoule per mole. This kj is kilojoule. Kilojoule. Then we have per mole. Per mole. So it is kilojoule per mole. So please take note of this. If you don't have an idea of the unit of enthalpy, even when you get the answer, your answer will still be wrong without attaching the unit for enthalpy. So the unit for enthalpy is either the joules or kilojoule per mole. Now the per mole, you can also write it like this. If you don't want to write it like this, you can also write it like this: kilojoule / mole. Are you seeing it now? So you can also write it like this or like this. So please take note of Take note of this. So from here, we'll be moving straight to exothermic and endothermic reaction. Please, if you find this class very interesting, I want you to subscribe to my YouTube channel at Divine Online Chemistry Tutorial. So from here, I'll be moving straight to exothermic and endothermic reaction. So I'll be starting first with exothermic reaction. Now, what is exothermic reaction? Now, please take note that exothermic reaction is a type of reaction whereby heat is given out to the surrounding from the reacting vessel. So please take note that exothermic reaction is a type of reaction whereby heat is given out from a reactive vessel to the surrounding. So please take note of that. Now I'll be using an illustration to explain this on the board right now. So let's say, for example, this is the reactive vessel. Now please take note that for heat to be given out from the reactive vessel, it means that the reactive vessel contains heat, because you cannot give out what you don't have. So for the reactive vessel to be giving out heat in exothermic reaction, it therefore means that the vessel contains contains heat. So for example, let's say this is the vessel and it contains heat. It contains Heat. And then in exothermic reaction, it therefore means that heat will be giving out. So heat will be giving out from every angle of the vessel. So we have heat here. Heat. So also have heat. And then also have heat here. So this diagram simply just explain exothermic reaction. Now earlier on, I said that exothermic reaction is a type of reaction whereby heat is given out to the surrounding. Now this is the surrounding. You see this part is the surrounding. This part is the surrounding. This part, they are the surrounding. So in exothermic reaction, heat is giving out to the surrounding from where? From the reactive vessel. So this happens to be the vessel, and then heat is giving out to the surrounding from here, from the reactive From the reactive vessel. And I said earlier on that for heat to be given out to the surrounding, it therefore means that the vessel contains heat. So please take note that for exothermic reaction, heat is given out to the surrounding from where? From the reactive vessel. So please take note of Take note of this. So from here, we'll be taking an example of exothermic reaction. So we'll be taking an example to explain this exothermic reaction properly well. And please take note that one of the examples of exothermic reaction is that of neutralization reaction. So I'll be setting the example on the board right now. Like I said earlier on, I said that neutralization reaction is one of the examples under what exothermic reaction. So let's digress a little bit to neutralization reaction. Now, what is neutralization reaction? Neutralization reaction is the process whereby an acid reacts with an appropriate amount of alkali to form what? Salt and water only. So salt and water are the two major products that are being formed under what? Neutralization reaction. And I come again, earlier on I said that neutralization reaction is the process whereby an acid reacts with an appropriate amount of alkali to form what? Salt plus water only. So this explains what? Neutralization reaction. So if you look at this equation, this just explains neutralization reaction. Now, like I said earlier on, I said that neutralization reaction is the process whereby an acid reacts with an appropriate amount of alkali to form what? Salt and water only. And I said earlier on that neutralization reaction is one of the examples under what? Exothermic reaction. So because it is one of the examples under exothermic reaction, then there will be heat. So it will be a plus heat. So please take note of what? Of this. So this explains what? Neutralization reaction under exothermic reaction properly well. So having illustrated this, now let's not use equation to explain this. Under acid, let's say we have hydrochloric acid here, which happens to be what? HCl, which happens to be a strong acid, plus sodium hydroxide, which is NaOH, which happens to be a strong alkali. Now, if you write it together, now we already know that the product that will be formed will be what? Salt and then water. Now, if you do this very well, if you write this very well, you see this sodium, we have to what? Bond with this chlorine to form what? NaCl, which happens to be the salt, plus, now you see this hydrogen here, bond with this hydroxide here, you get what? Water, H2O, plus heat. Plus what? Plus heat. You know that exothermic reaction is a type of reaction where heat is given out to what? To the surrounding. So there will be what? Plus heat here at the product what? Side. But please take note that under the neutralization reaction, an acid is reacting with what? An appropriate amount of alkali to form what? Salt and then water only plus heat. You must add heat to what? To it. So this is a typical example of what? Of exothermic reaction. I hope you guys understand this reaction. So from here, we'll be moving straight towards the next reaction, which happens to be what? Endothermic reaction. Now, what is endothermic reaction? Please take note that endothermic reaction is a type of reaction whereby heat is absorbed from the surrounding into what? Into the reacting vessel. So it's like the inverse of what? Of exothermic reaction. You know that earlier on when I was explaining exothermic reaction, I said that exothermic reaction is the process whereby heat is given out from the vessel to what? To the surrounding. But in endothermic reaction, in endothermic reaction, heat is being absorbed from the surrounding into what? Into the reacting vessel. So I'll be using an illustration also to explain this word endothermic reaction. So let's say this is the vessel. Let's say this is the what? This is the vessel, and then this is what? The surrounding. This is what? The surrounding what? The vessel. And earlier on, I said that in endothermic reaction, heat is being absorbed from what? From the surrounding into what? The reactive vessel. Now, from heat to be absorbed from the surrounding, it therefore means that the surrounding has what? Heat. So please take note that for heat to be absorbed from the surrounding, it therefore means that the surrounding has what? Heat. Whereby the vessel is what? Is cold. So the vessel is what? Is cold. Whereby the surrounding has what? The surrounding has what? Heat. So heat will be being absorbed from the surrounding into what? The vessel. So, and I said that this is the surrounding, whereby heat will be absorbed. So this is heat. Absorb, heat. You see, heat be absorbed from surrounding to the what? To the vessel. Same. From all parts of what? Of the vessel. So you also have heat here. Heat is being absorbed into what? From the surrounding into what? The vessel. So we also have heat. We also have what? Heat. So this typically explains what? Endothermic reaction. Whereby heat is being absorbed from the surrounding what? The vessel into what? Into the vessel. And I said earlier on, for heat to be for it to be absorbed from the surrounding, it therefore means that the surrounding has what? Has heat. Whereby the vessel is being what? Is being cooled. So heat is being absorbed from the surrounding into what? Into the reactive vessel. So this typically just explains what? Endothermic reaction. So please take note of what? Take note of this. So from here, we'll be moving straight towards some of the example of what? Of endothermic reaction. Now, one typical example that will be explaining here is what? Is the thermal decomposition of what? Of triazocarbonate 4. The thermal decomposition of what? Of triazocarbonate 4. So please take note of that. That the thermal decomposition of what? Of Ca or CaCO3 is known as what? Is known as what? An example of what? Of endothermic reaction. You know, this compound, most of us majorly call it what? Limestone. Yeah, it's correct. But the chemical name is what? Is what? Triazocarbonate 4. Also known as what? You can also call it calcium triazocarbonate 4. If you want to call it fully. So you can call it triazocarbonate 4. You can also add the calcium to it, calcium triazocarbonate 4. So please take note of what? Of this. But the thermal decomposition of this compound is an example of what? Of endothermic what? Reaction. So I'll be reacting it on the board right now. So the breakdown of what? Of CaCO3. So the breakdown of what? Of this CaCO3 will give you what? CaO plus CO2. So this is the thermal decomposition of what? Of triazocarbonate what? Or triazocarbonate 4. So this simply just illustrates what? An example of what? Of endothermic reaction. So please think that heat is being absorbed from the surrounding into what? Into the reactive what? To the reactive vessel. So this is one of the example of what? Of endothermic reaction. Now another example again of endothermic reaction is what? Is the melting of ice. Melting of what? Of ice. You know, ice is solid liquid. So the melting of ice, which happens to be H2O solid, don't forget, to give what? H2O liquid. So this is a typical example of what? Of endothermic reaction. The melting of what? Of ice melted to what? To give us the liquid. So please take note of what? Take note of this. So from here, we'll be moving straight to what? To energy level diagram of both the exothermic reaction and the endothermic reaction. So we'll be starting first with what? With the energy level diagram of what? Of the exothermic reaction. I'll be sketching on the board right now. Like I said earlier on, I'll be starting with first with what? With exothermic reaction. So the energy level diagram of exothermic reaction is like this, where we have diagram is like this. Okay, it looks like this. So the diagram looks like this. There at this part we have the reactant. We have the reactant here. Then at this part we now have the product. Then please think that delta H, which happens to be what? Change in heat content. Delta H is equal to what? Minus VE. Please take note that enthalpy or change in enthalpy for exothermic reaction is what? Negative. Reason because you know that in exothermic reaction, heat is being given out to the surrounding, which means rather we can also say that heat is being lost to the surrounding from the reactive vessel. Because heat is being lost, it therefore means that delta H is what? Negative for what? For exothermic reaction. So this happens to be what? The energy level diagram for what? For exothermic reaction. So please take note of this, that this is the energy level diagram for what? For exothermic reaction. And in this diagram, at this part, we have the reactant. Then at this part, we have what? The product. And then please take note that delta H is equal to what? Minus VE. So please take note that delta H is what? Is negative rather for what? For exothermic reaction. Reason because heat is being lost. So please what? Take note of what? Of this. So from here, we'll be moving straight to what? To the next energy level diagram for what? For endothermic reaction. So the diagrams looks like this for what? For the endothermic reaction. Diagram looks like this. So the sketches like this. And then we have so it looks like what? It looks like this. Then at this part here, we have the reactant. We have the reactant. Then at this part, now what? The product. So here we have the reactant, and then here we have the product. Please take note that delta H is equals to what? Plus VE. Reason because this is the energy level diagram for what? For endothermic reaction. So endothermic reaction. And in endothermic reaction, you know that in endothermic reaction, heat is being absorbed from the surrounding into what? Into the reacting vessel. So if you look at it very well, that's the reason why the delta H is positive, because heat is being what? Is being absorbed from the surrounding. But in the case of exothermic reaction, heat is being lost. Are you seeing this now? Because heat is lost, that one was what? Negative. Now, but because heat is being added to the vessel, thereby being absorbed in the vessel, it therefore means that delta H is what? Is positive. So please take note of what? Take note of this for what? For endothermic reaction. So from here, we'll be moving straight to what? To measurement of what? Of heat content of a chemical reaction. So from here, we'll be talking about what? Measurement of what? Of heat content of what? Of a chemical reaction. Now, please take note that there's an instrument for measuring the heat content of a chemical reaction. Now, please take note that the instrument for measuring the heat content of a chemical reaction is what? Is the calorimeter. So the calorimeter. So please take note that the calorimeter is what? Is the instrument for measuring what? The heat content of what? Of a chemical reaction. So please take note of this, that the calorimeter is used for measuring the heat content of what? Of a chemical reaction. Whereby the process of measuring the heat content of a chemical reaction is known as what? Calorimetry. It's known as what? Calorimetry. So this is the process. So calorimetry happens to be what? The process of measuring the heat content of a chemical reaction, whereby the instrument for now measuring the heat content of a chemical reaction is known as what? Calorimeter. So don't confuse the both of them. Calorimeter is the instrument for measuring the heat content of a chemical reaction, whereby calorimetry is the process of measuring the heat content of what? Of a chemical reaction. So please take note of what? Take note of this. Don't mislead what? The both of them. So from here, we'll be talking about the formula used in what? In calorimetry. Now there's an important formula used in what? In calorimetry. The formula is what? Is Q equal to MC delta MC what? Delta T. So this is the formula. This is the important formula used in what? Calorimetry. Hereby the M is equal to what? Mass. So please take note of this. And the M is what? Mass. Whereby the C is specific heat capacity. Specific heat is capacity. So C is what? Specific heat capacity. Whereby delta T is equal to what? Change in temperature. Change in what? In temperature. So this is the short form for what? For temperature. So please take note that delta T is what? Change in temperature, which happens to be what? T2 minus T1. So please take note of this, that delta T, which happens to be a change in temperature. To get the delta T, you have to do what? T2 minus what? T1. Whereby the T2 is what? Final temperature, and the T1 is what? Initial temperature. So please take note that T2 is equal to what? Final temperature. Final what? Temperature whereby the T1 is equal to initial what? Temperature. So please take note of this. So the initial temperature happens to be what? The first temperature you see in the question, whereby the final temperature happens to be what? The second temperature, and the last temperature you see what? In the question. So to get to change the temperature, you have to do what? T2 minus what? T1. So this is the important formula under what? Calorimetry. And calorimetry refers to what? The process of what? Of measuring the heat content of what? Of chemical reaction. So please take note of what? Of this. So from here, we'll be talking about what? Types of what? Calorimeter. There's some types of what? Calorimeter. But in today's lesson, we'll be majorly focusing on what? On two types of what? Of calorimeter. So like I said earlier on, we have several types of what? Of calorimeter. But in today's lesson, our major focus will be on the bomb calorimeter and the glass calorimeter. So taking the other types of calorimeter, we have what? We have the bomb calorimeter, and what? And the glass calorimeter. So please take note of what? Of this. That under the calorimeter, we have the bomb calorimeter and the glass calorimeter. So you please what? Take note of what? Take note of this. That under calorimeter, we have several types of calorimeter, but our major focus will be on what? On bomb calorimeter and glass calorimeter. Please take note that bomb calorimeter is used in what? In the combustion of what? Of fuel. So please take note of this, that the bomb calorimeter is used for what? For the measurement rather of the what? Combustion of what? Of fuel. So from here, we'll be moving straight to what? To heat of reactions. Now, under heat of reaction, we have several heat of reactions under. We have what? Now, the first one is what? We have heat of what? Of formation. We have what? Heat of formation. Heat of formation. We have what? Heat of formation. We also have heat of neutralization. Heat of neutralization. We also have what? Heat of combustion. We have what? Heat of combustion. So in the course of today's lesson, our major focus will be on what? On heat of formation, heat of neutralization, and heat of what? Of combustion. We also have other heat of reactions, but our major focus will be on what? On heat of formation, neutralization, and what? And combustion. So we'll be starting with the first one, which happens to be what? Heat of formation. Now, what is heat of formation? Please take note that the standard enthalpy of heat of formation of a substance is the heat change when 1 mole of a substance is formed from its what? From its element under what? Under standard condition. So please take note that the standard enthalpy of heat of formation of a substance is the heat change when 1 mole of a substance is formed from its element under what? Under standard condition. So to explain this heat of formation very well, I'll be using what? Water as an example. Now, under heat of formation, I'll be using what? Water. Then we have what? Now, in the formation of water, under heat of formation, we have H2. Under heat of formation, then we have what? H2 in gram plus half O2 in gram, that's oxygen gas, to form what? To form what? Water. That's 1 mole of what? Of water, which happens to be what? H2O. That's liquid now. So please what? Take note of this. And when I was explaining heat of formation just now, I said that heat of formation, I said that the standard enthalpy of heat of formation of a substance is the heat change when 1 mole of that substance, which is 1 mole of water, is formed from its constituent elements under what? Standard condition. So you can say that 1 mole of water is formed from its constituent element, which happens to be what? Hydrogen and what? And oxygen. So this is what heat of formation is just what? Trying to talk about where 1 mole of a substance rather it's formed from its what? From its constituent element under standard condition. So please take note of this. Now please take note that delta H for the heat of formation of water is equal to what? Please take note the value for delta H for the heat of formation of water, because this is what the heat of formation of water. This is an example. So please take note of this value. It is very important for those of us preparing for the 2026 JAMB examination. Please take note of what? Of this value. That the value for the standard enthalpy of heat of formation of water is minus 285.58 kilojoule per mole. So please take note of what? Of this value. Please take note of what? Of this value. This value is the value for what? For the heat content of what? Of heat of formation of what? Of water. So please take note of this. That the value for the heat content, then for the heat of formation of water is what? Minus 285.58 kilojoule per mole. So you please take note of what? Of this value. So from here, we'll be moving straight to the next one, which happens to be what? Heat of what? Heat of neutralization. So we'll be moving straight to what? To the next one, which happens to be what? Heat of what? Of neutralization. Now, what is heat of neutralization? Now, please take note that the standard enthalpy of heat of neutralization of a substance is the heat change when 1 mole of hydrogen ion, please take note that it's the heat change whereby 1 mole of what? Of hydrogen ion from an acid, reacts with what? 1 mole of what? Of hydroxide ion from a base, reacts with 1 mole of what? Of hydroxide ion from a base to form what? 1 mole of water, which happens to be what? H2O, under what? Under standard condition, whereby the hydrogen ion is aqueous, that's AQ. Hydrogen ion is still what? AQ, which is aqueous. Then the water is what? Liquid. So please take note of what? Take note of this. This what? Heat and neutralization reaction we're just talking about. Heat and neutralization. Please take note that the standard enthalpy of heat of neutralization of a substance is the heat change whereby 1 mole of hydrogen ion from an acid reacts with what? 1 mole of hydroxide ion from an alkali or a base synthetic to form what? 1 mole of what? Of water under standard condition. So this is what heat of neutralization is what? Talking about. So I'm explaining what heat of neutralization. So this is what heat of neutralization is what? Is talking about. So please take note of this. Please take note that delta H. Please take note that the value for delta H for heat of neutralization, because is what? Minus 57.4 kilojoule per mole. So this happens to be what? The value for what? For standard enthalpy for what? For the value for the heat content for the standard enthalpy of what? Heat of neutralization. So please take note of what? Of this value. I get the value for what? For that for water just now, which happens to be minus 285.58 kilojoule per mole. Now this happens to be what? For the heat of neutralization, that is delta H for heat of what? Neutralization is happens to be what? Minus 57.4 kilojoule per mole. So please take note of what? Of this value. So the last one that we'll be talking about is what? Heat of what? Heat of combustion. So this happens to be what? The last one. Now, what is heat of combustion? Now, please take note that the standard enthalpy of heat of combustion of a substance is the heat change when 1 mole of that substance is burned completely in excess oxygen. So it's the heat change when 1 mole of a substance is burnt completely in what? In excess oxygen. So when something burns completely in excess oxygen, the one we refer to as what? Heat of what? Of combustion. That's when something burns in excess oxygen. That will refer to as what? Heat of what? Heat of combustion. And earlier on, when I was explaining the types of calorimeter, I said that the bomb calorimeter is used to measure the heat content, the heat of combustion of what? Of the substance. So heat of combustion can be measured by using what? The bomb calorimeter. So bomb what? Bomb calorimeter. So please take note of this, that the bomb calorimeter is used to measure what? The heat of combustion of what? Of a substance. So please take note of what? Of this. So from here, we'll be moving straight to what? To entropy. Now, what is entropy? Please take note that entropy is a degree of disorderliness or randomness of what? Of a system. So please take note that entropy is what? Is a degree of disorderliness or randomness of a system. You know that in a system, there's a substance that are in random places. So the measurement of those substances in random places or in disorderliness manner is what we refer to as what? As entropy. So please take note of that. Now please take note that entropy can be represented by the letter S. So S is used for representing what? Entropy. Whereby change in entropy can be represented by adding what? Delta to it, which happen to be this triangle. So by adding delta to it, we now have what? Change in what? In entropy. So please take note of this, that delta S means what? Change in entropy. Whereby S is what? Entropy. So please take note of what? Of this. Earlier on, I said that entropy is the degree of disorderliness or randomness of what? Of a system. So you should please take note of what? Take note of this. Now, there's an important formula for calculating what? Entropy. Because entropy can be calculated. Now, there's an important formula for calculating entropy. The formula is what? Delta S is equal to delta H divided by what? By T. So, with this formula, we can calculate what? Change in what? In entropy. So, change in entropy, which happens to be delta S, is equal to delta H, which is known as what? Heat content, divided by what? By temperature. Now, please take note that the unit of entropy, is what? Joules, per Kelvin, per mole. So this happens to be what? The unit for what? For changing what? Changing entropy. So unit is equal to joules per Kelvin per mole. So this happens to be what? The unit for what? For entropy. Whereby temperature is always what? In Kelvin. T is temperature. T is equal to what? Temperature. So this is the short form for temperature in what? Kelvin. So T is what? Temperature in what? In Kelvin. They can give you temperature in degrees Celsius, but your temperature must always be what? In Kelvin. Now, to convert temperature from degrees Celsius to Kelvin, you simply add 273. You simply add 273 Kelvin to the value of temperature that they gave you in what? In degrees Celsius. So you simply add what? 273 Kelvin to the value that they gave you in degrees Celsius, then you get your temperature in what? In Kelvin. So please take note of what? Of this. Now, from here, we'll be moving straight away to the last part of today's lesson, which happens to be what? Gibbs free energy, or what? Free energy. So we'll be talking about Gibbs free energy, and this part happens to be what? The last part of what? Of today's lesson. Now, what is Gibbs free energy? Now, please take note that Gibbs free energy is the energy available to what? To do work. So please take note that Gibbs free energy refers to what? To the energy available to what? To do work. Most people call it Gibbs free energy. Most people call it free energy. Whether it's Gibbs free energy or free energy, is still the same thing. But please take note that Gibbs free energy is the energy available to what? To do work in the chemical system. So please take note of what? Of this. Now, this Gibbs free energy can be represented with this letter, capital letter G. Capital letter what? Capital letter G. Whereby change in Gibbs free energy. So you know that we have the number one, and then we now will change in. So this free energy can be represented by using this letter, capital letter G. Whereby change in Gibbs free energy can be represented by adding what? Delta. By adding what? Delta. You know, delta means change in. So Gibbs free energy, change in Gibbs free energy can be represented like this by adding delta to the work to this what? Gibbs free energy. So please take note of what? Take note of what? Of this. Now, there's a formula for calculating what? Gibbs free energy, because you can calculate Gibbs free energy. That's what is the energy available to do work. You can also what? Calculate it. Now, Gibbs free energy is equal to what? Delta H minus T delta S. So please take note of what? Of this formula. With this formula, we can calculate what? Gibbs free energy. Now, whereby delta G is what? Gibbs free energy. So please take note of this, that delta G is equal to what? The Gibbs free energy. Gibbs free energy. So please take note of this. Then delta G is what? Gibbs free energy. Whereby delta H is equal to, so please take note of this. Please take note of this, that what? Delta H is equal to what? Heat content, also known as enthalpy. So delta H is also equal to what? Heat content. heat content, also known as enthalpy. So please take note of what? Take note of this, whereby T is equal to what? Temperature. Temperature in what? In Kelvin. So please take note of what? Of this, whereby delta S is known as what? This delta S is known as what? Not entropy. So please take note of this. So all this constitutes the formula of what? Of this free energy. So delta G is equal to what? Delta H minus T delta S. So please take note of what? Of this. So please take note that the unit rather for this free energy is the joules. Is what? The joules. You can write it like this, or you can also spell it. This is Joule. But it's advisable to what? To write it like this, capital letter J. Joules or what? Or kilojoules. Or kilowatt joules per mole, rather. Kilojoules per what? Per mole. So please take note of what? Take note of this. So the unit of what? So unit of Gibbs free energy is what? Joules, or what? Joules, you add S to it, joules or kilojoule per mole. So please what? Take note of what? Of this unit. These are the unit for what? For Gibbs free energy. So with this, we have come to the end of today's lesson. If you find this lesson very interesting, I want you guys to subscribe to my YouTube channel as Divine Online Chemistry Tutorial. Don't forget to like my video. Don't forget to share my video. And don't also forget to comment to my videos. Bye, and see you in my next class.